So the title of the notes today, you are going to learn how to draw and analyze a segmented bar chart. It's a different type of bar chart that looks like this. And it's pretty darn easy, but in order to be able to draw one of these accurately, you have to be able to read a two-way table. So let's read this little review problem, see if we can answer these. A random sample of 200 students from the UK were asked their grade level and a preferred superpower. The two-way frequency table shows the results. So we have their grade level, whether they're 11th or 12th grade, and then what superpower they chose. Part A says we want to always be mindful of what our output, the form of our answer, needs to be in. So these are asking for percents. What percent of 11th graders? And so remember last time the way that we did these consistently so that we don't mess up, we'll read really closely. Out of all the 11th graders, so I want to look in the 11th grade column and see the total number of 11th graders in the survey. That was 104 of them. So that's going to be my denominator. Out of all of the 11th graders, how many chose invisibility? And that's just the 15 right up here next to invisibility, 11th grade. So if you'll remember, we just put this in the calculator. 15 divided by 104. Because it wants a percent, we need to be mindful of rounding. So I suggest that you bump your decimal over twice and then round to the nearest hundredth. So that would be 14.42%. And then I bet you can do B all on your own. What percent of 12th graders chose flying? When you think you've got it, just double check. And I'm going to ask you kind of an extended thing here. I mean, you have a quiz the next time I see you. I did not mention that, but it is up there on the board. And when I give you a quiz, I may ask you to recall there are 3 types of relative frequency, 3 types of questions, essentially, that you can be asked from a two-way table. And those 3 types are marginal, joint, and conditional. What are both of these? I want you to notice that both of the numbers for the green fraction come from the same column, and both of the numbers for the red fraction come from the same column. Do we remember which type that is? It's conditional. What is marginal again? If both of the numbers in the fraction come from the edges or the margins, good. And how are you going to know really fast that your word problem is a joint relative frequency? It's got the word and. Very good. So if you want to just add a little note. I mean, I won't see you guys again until Monday, and so if you're glancing back over your notes before the quiz on Monday, it might be good to see that. Okay, those are some skills that you're going to need. You've got to be able to read a two-way table today in order to draw a segmented bar chart. Before I show you how to draw them, you're going to need to know how to set up the axes. And so that involves you being able to look at your 2 variables and figure out which one is explanatory and which one is the response variable. And I'm thinking of the test that you're going to have later on down the road at the end of this chapter. And several of the questions on the test ask you if you can tell me the explanatory variable or the response variable in a scenario. So here's what an explanatory variable is. It helps to predict or explain, hence explanatory. It helps to predict or explain changes in the other variable, the response variable. And the response variable measures the outcome of a study. It's almost like a cause and effect, But towards the end of the chapter, we're going to talk about not all the time are we, when we compare two variables, is it a cause and effect relationship? So I kind of want to stay away from that wording. But if you can tell which one would help explain the other one, then that's your explanatory variable, and then by default, the other one's response. So here's what I'm talking about. Down here in example 1, if you had a test question like this, and it says, identify the explanatory and response variable for the relationships, and just kind of tell me why you think that. So on A, it says, here are our two variables. We've got an opinion about school lunch options. So that's going to vary from person to person, what your opinion is on what should be offered for lunch. And then the other variable is dietary restrictions. So out of those two variables, what do you think would explain the other one? What do you think would help predict the other one? Dietary restrictions would help predict a person's opinion about school lunch options. Why might that be? Why would somebody's dietary restrictions, what does that mean when you have a restricted diet? Give me some examples. Maybe they can't eat certain things. Maybe they're on a gluten-free diet. Maybe they have allergies. So that's going to predict somebody's opinion about what they think should be offered for lunch. So dietary restrictions would be explanatory. Those would help explain why somebody had an opinion about school lunch options. So that's the response variable. Before you can draw a segmented bar chart, you're going to have to be able to take the two variables and distinguish which one's explanatory, and you'll see why on the next page, because it helps you draw the bar chart. Part B says the availability of water, okay, and the word and kind of splits these apart. So as you read it, the availability of water is one variable, and the life expectancy is the other variable. In a sample of countries, which one do you think would help predict the other one or explain the other one? Would availability of water explain life expectancy, like how long somebody lives, or would how long somebody lives explain the availability of water? Which way does it go? Yes. How readily available a good, clean water source is. Spelled that wrong. I'm looking for my whiteout. There we go. Availability of water would explain why some countries might have a longer life expectancy. So that would be the response variable. That would be the outcome of the study. And so far you might be thinking, I thought we were going to draw bar charts. This doesn't really seem to have anything to do with that. But we're getting to it on the next page. When you turn the page, I'm going to move through this little dotted box pretty quickly here. This is how to make a segmented bar chart, but I think, you know, a lot of you are going to learn better by just actually doing it down at the bottom of the page. So let's fill in these blanks. I'll discuss it briefly as we go, and don't worry if you're kind of still fuzzy on a couple of these steps. The very first thing that you have to do is identify the explanatory and response variables. Here is why you have to do that first. Because when you draw your axes, the explanatory variable goes on the horizontal axis. But keep reading, because you're not going to read, oh, then the response goes on the vertical. No, the explanatory goes on the horizontal axis, and percent or proportion goes on the vertical axis. So those percents and proportions we've been getting as answers from two-way tables, that's what I'm talking about. Okay, then you're going to scale the axes. You're always going to make sure that your vertical axis starts with 0 and ends at 1 or 100%. So if you make a bar chart and you want to make everything into percents, then you'll go all the way up to 100%. If you do it the way I'm going to do it today and you do proportions, then that's 1 whole would represent 100%. So you'll go all the way up from 0 to 1 whole. So you're going to count by like 0.2s, 0.2, 0.4, 0.6, 0.8, 1. It's really easy. Then, this is one of the only types of bar charts you're already going to be able to know exactly how tall to draw each bar. You're going to draw each bar all the way up to 1 or 100%. And then where the mathy part comes in is step 5. You're going to make the segments. And to do that, you're going to have to calculate the relative frequency. That's what we practiced last class. Find the proportions for each category of the explanatory variable, and then you're going to divide the bars up. And the areas of each segment corresponds to the proportion. Okay, blah, blah, blah. The last one is very, very important. You're going to have different segments, so you're going to have to shade each segment differently. Maybe you shade and leave a blank one, or maybe you stripe one in. Well, I need to know what's what, so be sure that you include a key. Without the key, it's useless. All that hard work that you just put in is useless. Let's actually look down here. This is the Titanic data that we saw last time in our notes from 3.1. So we have the class of travel. These are all the adults on the ship, whether they travel first, second, or third class. So that is one of the variables, is what was their class of travel. And then over here, survived and died, we'll call that survival. That would be the other variable. Now I have to determine right away out of these two which one is the explanatory, because that's going to go on the horizontal axis of my bar chart. It says, make a segmented bar chart to display the relationship between survival status and class of travel. So survival, I guess, status. Okay. So let's make a little note. Out of those two, which one do you think explains the other? Class of travel would explain survival status. And you guys have heard and had discussions about the Titanic in different arenas of your life. Why would class travel possibly help predict whether somebody survived or died on the Titanic? What do you think? What have you learned about that whole situation? Yeah, the first class travelers were the first ones to be able to get to the lifeboats because they were seen as, you know, the more important people. As a matter of fact, some men even got on the lifeboats and left women and children behind in the lower classes. And so that's an unfortunate thing, but in this situation, the explanatory variable is going to be class of travel. Survival status is going to... Oh. I don't know why I wrote that, you guys. My brain. I think I'm already on the road. This is response. And that's going to be survival status. Maybe some of you were completely confused because of what I had written up there. Sorry about that. Explanatory, class of travel, and response is survival status. Here's how I'm going to organize all my stuff at the bottom of the page. I'm going to draw the bar chart over here on the kind of left, and then I'm going to do all of the math, show all of my work over here on the right. So if you want to copy the way I do it, then that's kind of how to divvy up your space. Go ahead and draw a vertical and horizontal axis, and give yourself enough room. Like, don't make it microscopic, okay? Well, up there at the top of the page, it says draw and label the axis, and the explanatory variable goes on the horizontal. So here's what I now know. I'm going to have a bar for first class, a bar for second class, and a bar for third class, because class of travel was the explanatory. That's what goes down here. I'm not going to put survived and died because that's the response variable. Part 3 says scale your axes, and so your vertical axis must start with 0 and go up to, let's do proportions. So we're going to count to one whole. I'm going to do 2, 4, 6, 8, so 0.2, 0.4, 0.6, 0.8, one whole. Try to space those out as evenly as you can. So this is the relative frequency. If your word problem does not specify percentages or proportions, I would always just do these because it's one less step. Step 4, again, this is kind of a weird feeling because normally we have different heights of bars in a bar chart. But the way you draw segmented bar charts is you're going to take a first class bar and you're going to draw it all the way up to the 1 representing 100% of the people who traveled first class. Same thing for second class, 100% of the people who traveled second class. And 100% of the people who traveled third class. They all go up to 1 or 100%. Okay, now it's time to do the little mathy bit out to the side. I'm going to have to take this first class bar and I'm going to have to separate it into who survived and who died. So think of it that way. Then I'll have to do the same for second and the same for third class. So over here, organize your thoughts. And so I'm going to first figure out who traveled first class and survived, and who traveled first class and died. And I'm just going in the order that it is right here on the page. Survived is on top of died. Okay. Just look at the first class people. So 319 of those. How many of those people survived? 197 out of 319. And as far as those who died in first class, that's 122 out of 319. Let's change those into decimals. 197 out of 319 is 0.62, and 122 out of 319 is 0.38. Couple of little things to notice that will help those of you that that like little patterns that make things easier in math. Look at these denominators. They're both 319. So both of the first class denominators match. Okay. Also, what do these numbers for all the first class passengers, what do those decimals add up to? One whole, or representing 100%. Okay. So that's a good way to check as well. So you should get something close to 1. So here's what we're going to do. Let's go to our first class bar. And actually we need to make a key really fast. We only have 2 different survival statuses. So we just need to make like maybe a shaded and a non-shaded segment. And however it's written on the page, like survived is on top and died is on bottom, that's how I'm always going to keep it. Otherwise it can get really confusing. Survived will be the top segment and it'll be shaded in, and died will be the bottom segment and it'll be blank. So here's what we need to do. The bottom of the first class bar, the proportion of people who died, is going to go up to 0.38 for died. 0.38 So just below the 0.4. And then everybody up here survived.
They literally just called me to another one. So I
Oh.
wrote that one, we're gonna knock this one out,
Okay,
let you know.
great, no problem. Not in a rush. Thank you. All right, let's do the same thing for second class. So let me find a different color here. Second class survived. Go in the same order and it won't get confusing. Second class died. So you've got to be able to read that two-way table. Second class, 261 is going to be my denominator for both of those. 94 people survived and 167 people died. Now don't just take my word for it. Don't go on autopilot here and just copy stuff down while you're daydreaming. Take part in your learning. Find those proportions. They should be somewhere close to 1. Sometimes when you're rounding, you might be a little off. You might get something like 0.99 or 1.01. Those are fine. But here we happen to get 1. Now I'm going to go to the second class bar and I'm going to divvy it up accordingly. The bottom part, the blank part for died, is going to go up to 0.64, and then everything above that will be shaded. So 0.64. And without the key, I wouldn't know what segment represented what. So the key is very important, not only for the creator of the bar chart, but for the person reading it. Do you see a difference here in the proportion of people who survived based on first or second class? Can you tell that there was a big difference? Yeah, and we're going to see that again in third class. So third survived, and third died. I'm looking in this column right here. 627 total people. $151 survived, 476 died, and that's pretty sad. The whole situation was pretty dire. So more than 75% of the third class passengers died on the Titanic. So 75. If you have different colors and you want to like make the segments different colors, you can. If you run out of options and you need to make one of the segments striped, like we're going to need to on the next one, you can do that. So there's all different kinds of ways you can differentiate the segments. Now that's how you build a bar chart. That is how we do that. The next piece of today's notes, so we're already on the last page of notes. This is nice. The last page of notes is this. It says association. So here's what's really, really important. Not only that you can make one of these, that's great, but you're not going to have to make one of these on a multiple choice test, are you? So what you need to be able to do for a multiple choice test is you need to be able to look at a bar chart that's already made and tell me, is there some kind of relationship between the variables or not? Here's a really good example, okay? If you look at a bar chart, you have to determine if there's any association between the variables or not. Determine if there is any association. Here is the bar chart that we just made. The segments are flipped the way we did it, which is fine. So this is the Titanic data. class of travel, and they did percentages instead of proportions, but it's the same exact thing we just did. And what you told me is you could clearly see there was a big difference between who survived and who died because these segments are at different places. So this shows that there is an association. I want you to write shows association between class travel and survival status, because the segments are uneven. It's really hard to put into words what I mean. When I say the segments are uneven, I don't mean that the bars aren't split in half. I just mean that, like, this one's way up here, this one's split way down here, and this one's even lower. So it's those that I'm talking about, those different levels there. Okay? Versus something like this. What do you notice about this one? Yes, they're straight all the way across here. If you ever see a segmented bar chart and the segments look like the same exact height across the board, then there's no association here between, this would be class of travel and survival. So we know that whoever made this made it incorrectly because this is the Titanic data, but this shows no association. No association between variables because segments are the same across the bars. Segments are the same across the bars, and it might help if you just draw yourself a little line across there. Okay, so that was the second piece of what I needed to tell you today. Not only do you need the skill of making one of these, but you need to be able to analyze it, and it's really easy. If everything's all jumbled up and uneven, yes, there is an association. If everything is nice and neat and straight across, then there's no association there. So we only have one more thing to do, and this should go by a little bit faster than the last one. We're going to make a segmented bar chart. Let's read what it's about, and then we'll answer part B to see if there's an association or not. Put everything together that we've talked about today. Do adult and juvenile eastern gray squirrels of New York, I shouldn't say now York, New York Central Park exhibit different behavior towards humans? That is one of many questions investigated by the 323 volunteer squirrel sighters in October 2018. Here are the data for 2,898 squirrel sightings near the park. What are the two variables? If you're staring at this two-way table, what are the two variables? I'll give you a hint. The two variables here were class of travel and survival status. So what were you saying?
Age and behavior.
Age is one of the variables. Are the squirrels young or old? Are they juvenile or adult? So that's one of the variables. And the other variable is behavior towards humans. Look at those. They either approach the human because they're not scared at all. They're indifferent. What does that word mean? They don't really care. They're not bothered by the humans either way. Or maybe they're really scared and they run away. So those are the three behaviors in age. Okay. Now, if we're making a segmented bar chart to see if there's a relationship or not, then for part A, the very first thing that we must do is decide what the explanatory variable is, because that's how we're going to title our horizontal axis. It helps us know how to divide this up. So should we put a bar for approach, indifferent, and runaway, or should we put a bar for juvenile and a bar for adult? Well, which one of these might explain the other? Age might explain, exactly, age is probably going to explain whether a squirrel is scared or not scared or doesn't care about a human. So age is going to be explanatory. Now I know I'm going to have a bar for juvenile and a bar for adult. And we'll just say the response is behavior. Okay, go ahead and draw your axes. We're going to do this one the same way. We're going to have one for juvenile and a bar for adult. We'll start at 0, 2, 4, 6, 8, 1 whole. You can go ahead and draw each bar up to 1. There's something kind of tricky about this one though, about this, how we draw this. So even if you think, I've got this, I understand, I'm moving on, I don't need to listen to her, there are a couple of things in here that I haven't mentioned yet that are really important. That can mess up the whole thing if you don't know them. Okay, let's go off to the side now and do our math. We need to divvy this up. We need to take the juvenile and we need to split it up into approach, indifferent, and run away. That's for my juveniles. And then if you want to know what we're going to do after that, we're going to take the adults and split them up the same way. Approach, indifferent, run away. I'm a person who really likes patterns in math. It's how I survived high school math. I just found patterns. So my denominator is going to be the same for all the juvenile fractions, and it's going to be 330. And I stacked these how they were in the table, approach, indifferent, runaway, so I can just take the numbers 111, 138, and 81. And I'm going to do the same thing. Holy cow, there are a lot more adults. 2,568 of those. 756, 1,241, 571. Do this, get your decimals and stop. Don't do the segments yet because that's where the tricky part is. So just get all of these decimals here. And because we've got 3 different decimals that we rounded, you're going to see that when we add them together, we don't get exactly 1, but we get really close to it, and that's okay. And when you've got your numbers, just double check with mine, make sure that you're good to go on those, but don't draw the segments in. I'm scared for some of you because I hear you already coloring in the bars, and I'm not sure you did it the right way, so hold off on that, okay? Is everyone good with these decimals? If you weren't looking up here earlier because you were kind of looking at what you were doing, just make sure you know you're not always going to get exactly 1 whole, and that's okay. Don't freak out and think, oh no, I need to change the numbers somewhere. We're good on that. Now, go ahead, let's make a key we've got 3 different segments because we have 3 different behaviors. So let's maybe do a shaded, a stripy, and a blank. Approach goes on top. Indifferent is in the middle. And runaway will be on the bottom. And I always do it the same way, in the same order that I did all my work. Otherwise it can get confusing. Now I may not have said this earlier because it's kind of one of those things I think you would just get anyway without the teacher telling you, but you need to make sure that your segments are in the same order for juvenile. So if you do blank, stripy, shaded, then you also need to do blank, stripy, shaded on adult. Now, here's why I told you to wait. Go ahead and make your runaway section of the juvenile, start with the bottom, and go up to 0.25. That's not something I think that you would mess up on. So juvenile, go up to 0.25 and draw a line, and everything under that represents the proportion who ran away. Now here is where I need you to pay really close attention. You are not going to draw your next line up at 0.42. Why not? It says 0.42. Why can't I just come over here?
It's an addition.
Exactly. The entire segment is 0.42 tall. So what would I need to do to figure out where that goes? You would need to add, right? Now that's easy, but you needed to hear me say that. So add 0.42 to the section below it. So you know that the entire stripy section goes up to 0.67. So we're now all the way up here to 0.67, and I want you to actually write in the bar what you just did. You added 0.42 to 0.25 to get 0.67, and that's how you knew to draw that next segment up there at 0.67. And then I'm going to stripe that in. And that's kind of the only thinking that I have to do, because the other one, the rest of these should be the proportion of adults who, or juveniles who approached. And I can go ahead and check. That should be 0.34. So from 0.67 all the way up to 1 whole is about that. So we're good. You're going to be asked to read these on a multiple choice test. So you'll have to know that that segment right there involves some kind of addition or subtraction. Okay, now that you know how to do that, let's get all the way through the adults. So go up to 0.22 for runaway. And for indifferent, we're going to add 0.48 to 0.22. That takes us all the way up to 0.7. If you're doing this for your homework, you don't have to show the math in the bar like this, but I'd like it for you to put it in your notes. All right, we've got all the little squirrelies represented here. So we did part A, and it looks really pretty, but do we know how to analyze it? Is there an association between juvenile and adult, the age of a squirrel, and how they act towards humans? What did we say up here? If the segments are kind of look like they're the same all the way across, there's no association between the variables. And it looks like the way that we drew it, yours should be pretty close to this, that they're segmented the same way. So find a place to squeeze in the answer to part B somewhere. Now, the way you word things in statistics needs to be, you need to be careful because there's got to be some wiggle room in there. We don't really make any definite statements. So write it as, there does not seem to be an association there does not seem to be an association between age and behavior of squirrels, so we know what we're talking about. Squirrels. And that is 3.2.